Ah, traveler, why do some notes sing together in harmonious wonder, while others claw at our ears with tearing dissonance? According to physics, there is such a thing as the most dissonant chord. Imagine a graph, full of valleys and peaks. The valleys are places of sweetness and rest, major chords, minor chords, suspended beauties. The peaks are spikes of harshness, combinations that rasp and growl. This graph is not art. It is mathematics, and yet it seems to line up uncannily with our musical instincts. But here's the twist. With just a tiny change to the sound, those same chords, once restful valleys, leap up into the peaks of dissonance. Even the octave, the most precious of intervals, can be twisted until it sounds badly out of tune. How can that happen? Let's find out. Today on the Root Note Roost, I, Kaepo the Owl, will show you how the physics of dissonance shapes everything from scales and harmonies to the very sound of cultures. Let's give it a hoot, shall we? Part 1. The Zone of Discomfort. Beginning with pure sine waves, the simplest sounds imaginable. If you play one steady note and slowly raise another alongside it, you'll notice something strange. At first, they fuse into one smooth pitch. But as the second drifts upward, the second begins to wobble, growing rough and tense. That's called beating. Two waves sliding in and out of phase, first reinforcing, then canceling each other. Our ears add to the mischief. The cochlea, deep inside, cannot perfectly separate nearby frequencies. It smears them like a painter with a heavy paintbrush. Two close notes blur together, but the blur feels jagged and restless. Only when they move far enough apart do we hear them as two clean voices again. This is the space occupying the interval of a minor second. The Ocarina of Time title screen theme and the infamous Lavender Town from Pokemon Red, Blue, Yellow are songs that use this zone of dissonance to their advantage in game music, causing suspense and tension, but also beauty and emotion, using half-step movements. Lower Norfair from Super Metroid, and Horrorland from Mario Party Superstars 2. Starting with Ocarina of Time title theme, and that unforgettable melody. Pretty, huh? Now for a darker twist. In Lower Norfair, Super Metroid, the bass line we see is and again in Horrorland, Homestretch, Mario Party Superstars, we have our chromatic movement. So thus, the physics of dissonance gives us a zone of discomfort, two notes that are too close to be friends, too far to be one, a place of tension. And yet, with pure sine waves, that's all you get. No magical octaves or fifths, no special harmonies, just sameness, or personal space. For harmony, we need more than fundamentals. We need overtones. Part 2. The power of overtones. Every real sound is not a single frequency, but a family of them. A plucked string, a pipe of air, a drum skin. Each produces a fundamental note plus a stack of overtones. Strings and pipes give us the harmonic series, clean multiples, 2 times, 3 times, 4 times, and so on. A bell, however, gives a messy spread of partials. A bar or gong has its own fingerprint. When we hear two notes, our ears are not judging just the fundamentals. They are juggling every interaction between every overtone. Some pairs line up neatly, canceling dissonance and carving out a valley. Others clash, stacking discomfort into peaks. And here's the revelation. Contrary to the peaks of dissonance, we have the consonant valleys that run deep as well. They lie exactly where Western music built its most cherished intervals. The octave, the fifth, the fourth, the major and minor thirds. They are not arbitrary. They are peak softness, the low points of roughness, and the resting places of overtone physics. We can explore these valleys of consonants in songs like Undertale's Home, Zelda's Lullaby, and Kirby Dream Land's iconic Green Greens. Undertale's Home is delightfully consonant. Take a listen. Here, we can hear how pleasant and orderly it all feels. That's the power of harmonic overtones, bringing out specific feelings and emotions in us through patterns and relations of sound harmonics. Zelda's Lullaby. Additionally, change the instrument, change the overtones, and the map changes completely. Play bells or gongs, and suddenly the Western intervals turn sour. New valleys appear, pointing to entirely different scales. This is why different cultures with different instruments, gamelan in Indonesia, classical bars in Thailand, evolved scales that sound strange to Western ears, yet are perfectly natural in their world. The instrument's tone color has an effect on the harmonics, believe it or not. The Bazaar in Legend of Zelda: Skyward Sword shows us the power of tone, color, and tempo. I absolutely loved how they did this in the game. I wonder if they sell snacks. Oh, and if you listen to Hailfire Peaks from Banjo-Tooie, both the icy side and the lava side variations, you'll notice it's the same song. Yet, it sounds so vastly different. You can feel the dissonance shifting along with the transitioning tone colors. This is overtones subject to instrument timbre. So no. The octave is not carved into the stars. It is carved into the wood of the violin, the pipe of the flute, the throat of the singer. Harmony is not just physics. It is instrumental physics. Part 3. Dissonance builds scales. Now, traveler, let us climb higher on the overtone ladder. Add one overtone, and you find the octave. Add another, and out comes the fifth. Add more, the fourth, the major third, the sixth. Layer upon layer, the valleys multiply until you have enough consonant notes to weave a scale. This is why so much of human music leans on strings and pipes. Their harmonic overtones yield fertile valleys, so to speak, with lots of variation and options, giving us the tonal building blocks of their scales and chords. The system your piano uses is only an approximation. It slices the octave into 12 equal steps, nudging notes close to valleys, but never perfectly. Some intervals, like the equal-tempered major third, actually do land near dissonance peaks. This is where we have the strange phenomena when you play a pure, justly tuned third. It feels smoother, but also harder to use across keys. Equal temperament is a compromise. It sacrifices perfect valleys for the freedom to roam anywhere. Video game music using its major thirds predominantly, with an appropriate instrument tone color and overtone set, would be Cyber's World from our beloved Deltarune, written by Toby, for example. here's another beauty. The imperfections give Western music its restless shimmer, the sparkle of chords that are never perfectly still, always in motion. Part 4. Dissonance shapes chords. Now we return to that graph from the start, the landscape of hills and valleys. Each point represents a chord. Root, second note, third note. Peaks equal harsh dissonance, valleys equal consonance. Follow the valleys and you find major chords, minor chords, suspended chords. These are the islands of harmony where our ears feel at home. They consist of stacking two major or minor intervals on top of each other, creating clusters of three notes with two spaces, or distances between them. The distance between them alters the dissonance and harmony. Utilizing these dissonances to their advantage, we have Luigi's Mansion main theme and Undertale's Your Best Nightmare. Now, Luigi's Mansion main theme. Even spookier, you say? Let's soar to it. Now, straying into the peaks, and you find certain clusters of roughness, the most dissonant chords. But here's the truth. Most three-note combinations sound dissonant. That's why the valleys are so precious. They are rare oases in a desert of roughness. A song that uses extremely dissonant chords? Can you think of a particularly spooky place in Ocarina of Time? That's right, the Shadow Temple. You can feel the intensity and anxiety it brings, can you not? Many game creators use these interval stacks in scary levels and horror games. We also see its use in The World Revolving, Deltarune. The underground theme from Super Mario Bros. Too. The tritone. And just as with intervals, change the overtone structure and the map shifts yet again. A drum yields different valleys than a string. A synthetic sound built from prime number overtones yields still another harmony. Harmony is relative. The valleys belong to the instrument as much as to the ear. The lesson of dissonance. So, what do we learn from all this, traveler? That harmony is not universal. It depends on the alignment of overtones. Strings and pipes gave us octaves and triads. Bells gave us different scales. Gongs gave us gamelan. An interesting theory nonetheless. Keep this in mind next time you're playing your favorite video game. Game composers have a vast level of knowledge using dissonance, harmony, and tone color, and they tailor their music to the levels themselves most of the time. But you know, the tritone, once called the devil's interval, is not inherently evil. The tritone is an unstable interval consisting of 3 whole steps, or 6 half steps, which also happens to divide an octave in half. On the dissonance graph, it looks no worse than a minor sixth. Whole steps and half steps are inherently dissonant. They live in the cracks, not the valleys. They are tolerated only as bridges between consonant notes. In the end, harmony is not just art, not just mathematics, not just psychology or science or culture. It is all of them, braided together. And physics shows us why certain sounds feel restful and why others scratch. It shows us that a note is never just one frequency. It is a forest of overtones, each branch rubbing against the branches of another tree, like a beautiful symphony of all the most delicious snacks in the world. Forgive me, traveler. I do get carried away. Sometimes I feel like harmony itself is a bird's nest, fragile twigs all leaning on one another. And sometimes Dissonance is not a flaw, but the wind in the branches that makes the nest sing. Now, I think I've earned a little snack. Today's treat, dried cranberries. Tart, a little dissonant on the tongue, but balanced by their sweetness, much like a major 7th chord. Really? If you enjoyed this video, love musical science and video games, or maybe owls, please subscribe. Leave a comment sharing your favorite dissonant or consonant video game track. And until next time on the Curiosity Bop, may your ears find valleys of peace amid the peaks of dissonance. Have a great day!